April 12, 1981, Kennedy Space Center. The sun is low, the Atlantic is sparkling, and 800,000 people are holding their breath. Then the loudest man-made sound in history tears the sky open. Columbia claws upward on a 4-million-pound thrust firestorm. The crowd is screaming, engineers are crying, commentators are losing their minds. In that exact moment, every single person on Earth believed space travel is about to become as common as flying to Paris. They were dead wrong. Every single shuttle flight ended up costing taxpayers $1.6 billion in today's money. That's 22 times more than a Falcon 9 that now lands itself on a floating pad like it's bored. So how did the most beautiful, winged spaceship that looked like the future become the most expensive mistake in NASA history? Let's start with the machine itself. Imagine two skyscraper-sized fireworks you can't turn off once lit. One disposable orange tank the size of a 15-story building, and a gleaming white space plane literally strapped to the side like an afterthought. 3 RS-25 engines in the back, the most powerful, most complicated, most beautiful hydrogen engines ever built. And covering almost the entire underside, 24,000 handmade ceramic tiles that had to be individually inspected, measured, and often replaced after every single flight. Here's the party trick that still blows minds. The liquid hydrogen that explodes inside those engines is so cold, minus 253 degrees Celsius, that engineers pump it through hundreds of tiny tubes inside the engine walls first to stop the metal from melting. Same fuel that creates the fire keeps the fire from destroying the engine. Regenerative cooling. Absolute genius. Also, absolute pain. Those engines had to be removed, torn down to the last bolt, and rebuilt after every mission. In orbit, the shuttle was a monster. Robotic arms snatching satellites like an arcade claw machine, saving Hubble, hauling entire laboratory modules the size of school buses up to the ISS. It was a flying construction crane, science lab, and delivery truck in all one. Coming home was pure Hollywood. Tail first deorbit burn, belly glowing cherry red at 1650 degrees Celsius, S-turns across the sky bleeding off Mach 25 speed, then bam, 350 kilometers per hour runway landing with a parachute popping out the back. It looked unstoppable, until it wasn't. January 28, 1986, freezing morning in Florida. Ice on the pad, engineers begging to delay. Management says go. 73 seconds later, Challenger explodes in a twisted Y in the sky. 7 astronauts gone. Cause? A $2 rubber O-ring that got too cold and couldn't seal. February 1, 2003. Columbia is gliding home from a routine science mission. A suitcase-sized chunk of foam, something they'd seen peel off dozens of times before, punches a hole in the left wing on launch. Nobody fixed it. On re-entry, plasma hotter than the surface of the sun pours into the wing and eats it from the inside. 7 more astronauts gone. Both disasters 100% preventable. Both caused by the exact same poison. Normalization of deviance. It's always been okay before, so it'll be okay again. That mindset killed 14 people and almost killed the entire American human spaceflight program. NASA promised 50 flights a year at $20 to $30 million each. Reality, best year ever is 9 flights. Average cost is $1.6 billion per launch. Total program cost, roughly $220 billion over 30 years. That's enough money to launch 3,000 Falcon 9s at today's prices. Here it is, the one sentence you came for, the one that ends every debate forever. The Space Shuttle tried to reuse everything and ended up reusing almost nothing. While modern rockets reuse only the most expensive part, keep everything stupidly simple, and fly 50 times more often. Lock these 5 brutal truths into your brain, they decide who wins space from now on. Surfaces are insanely expensive. Every wing, hinge, gear door, and one of those 24,000 tiles needed human hands after every flight. Mass is a ruthless tax. Every kilo spent on wings, landing gear, and a huge crew cabin is a kilo you're not sending to orbit. Cadence destroys cost. Fly 5 times a year, and your 30,000 employees still want paychecks 365 days a year. Fly 50 times a year, and those salaries become cheap per flight. Solid rockets are a marriage with no divorce. Once they light, you're riding that thing to the end, good or bad. Complexity is a silent killer. The more parts that have to be perfect every time, the more places almost perfect can hide. Are space planes coming back? Yes, but watch carefully. Dream Chaser, X-37B, ESA Ride Spacer, Chinese and Russian prototypes, all tiny, cargo first, riding on top of normal rockets, gentle runway landings only when it actually pays for itself. They kept the sexy part and threw away the suicidal complexity. Meanwhile, rockets grew up and got mean. One big aluminum tube, 9 engines, a few hundred heat shield tiles. Landed on legs with pinpoint precision. Fly the same booster 20 times in a single year. That's the cheat code Elon figured out. Starship is just that idea on steroids. Your permanent cheat sheet for every future launch you watch. See wings and tiles? Ask, what exactly does this buy me, and how many thousands of people does it take to touch it after landing? See solid boosters? Ask, how many minutes into flight does the crew have no good abort? See a clean cylinder that lands on legs? Smile. That design is eating everyone else's lunch. Columbia's first launch still gives every space nerd goosebumps. But the future doesn't live in 1981. It lives in Boca Chica, Cape Canaveral, and Starbase, where boosters flip, hover, and gently sit back down like they're bored. The fastest path to cheap, boring, everyday spaceflight turned out to be the simplest one. Reuse the expensive part. Throw away the cheap part. Fly so often the accountants cry happy tears. Smash subscribe and the bell right now. See you at the next launch.